Now, let's consider the distance of 2 points. The first example says that find out the distance between 1 and 5. We know 1 is here, 5 is here. So the distance is 1, 2, 3, 4 is 4. How did we get 4? 5 minus 1. You see, 5 minus 1. So you find out the difference. Then you will be able to find out the distance. So the difference of two numbers is the distance of these two numbers. Those 1 and 5 are positive numbers. If we look at negative 2 and 3, negative 2 is here, 2 units to the left, 3 is 2 units to the right. So what's the distance? Everyone knows it's 5. How did we find out? It's again the difference of two numbers. 3 minus negative 2. Okay, you see 3 here, negative 2 here. So 3 minus negative 2 minus a negative number. Negative is positive. So it's 3 plus 2, which is 5. Okay, so we can put 5 here. Now those are just in one dimension. How about like two-dimensional space? Right here. Right here we are given A, negative 1, negative 2, and we are given B, 3, 2. How are we going to find out the distance between A and B? We know the horizontal distance between AB is this part. It's this long from here to here. That's B. Horizontal distance would be used 3 minus negative 1. That's horizontal x direction. 3 minus negative 1 is 3 plus 1, which is 4. Choose absolute value is still 4. So this B is actually 4. Okay, so B equals 4. We want to mark it here. What is the vertical distance between A and B? The vertical distance you will consider y. Y from negative 2 to positive 2. Okay, so you use the previous formula, the difference. The vertical distance between A and B is 2 minus negative 2. So it's this y value minus this negative y value. 2 minus negative 2 is 2 plus 2, which is 4. Choose the absolute value is still 4. So here A, the vertical distance, is also 4. Alright. Now we know in this right triangle, A squared plus B squared is C squared. That's Pythagorean theorem. So we know A squared plus B squared is C squared. You may choose the square root. Then left hand side is just C. Right hand side is A squared plus B squared. A squared we know is 4. And you know, if you write original expression, that's 2 minus negative 2. You may put here. Okay. Yeah, 2 minus negative 2. You may put here. That's actually, 4 squared. And then B squared, B is this part. We know B squared is 4 squared. Okay. But you may also write 3 minus negative 1 here. Okay, because 3 minus negative 1 is 4. You may write 4 squared here. You may also write the original expression, 3 minus negative 1 squared. Okay, so radical a squared plus b squared, okay, or a squared plus b squared here. This is 4 squared plus 4 squared inside radical sign, and then you know there is a 1 in front of 4 squared, 1 in front of 4 squared, okay, because 1 times 4 squared is still 4 squared. Here there is 1, here there is 1, together is 2 times 4 squared. Inside the radical sign there is a 4 squared, so 4 can be out. 2 stays inside the radical sign. Okay, so the final answer of the distance between A and B is 4 times radical 2. Okay, that's the hypotenuse of this right triangle. And this would be the formula for the distance. The first one is the difference of axes, is the horizontal distance. The second one is the vertical distance. So you want to square the horizontal distance plus the vertical distance squared. Choose the square root. That's the formula. Okay, x, the difference of x is like previously, difference of 5, 1, and the difference of 3, negative 2. You always choose the difference. Okay, and here the horizontal distance is 3 minus negative 1. Okay, and then you square that, and plus vertical distance squared, choose the square root. That would be the distance of the 2 points. Now, why do we need to talk about that? If we look at the following example, it's going to be very useful. Look, this one says that find the equation between 2 points. One is P1 is negative 1, 2. Negative 1 is on the left, 2 unions up. So this is P1. And P2 is just xy. So it can be anywhere. So P2 xy with distance 3. So we want to find an equation between 2 points with distance 3. We know the horizontal distance between P1 P2, the horizontal distance is A, is this part, from this point up to this point. That's the horizontal distance. Horizontal distance is the difference of axes. So x minus negative 1, which is x plus 1, choose absolute value, is A. Similarly, the vertical distance between P1 and P2, is B. That's the difference of y. Okay, so here is y minus this positive 2, y minus positive 2. Choose the absolute value is B. That's the vertical distance. Now we have a horizontal distance A, vertical distance B. We know by Pythagorean theorem, a squared plus b squared is c squared. 2 legs squared separately is hypotenuse squared. Now this leg is x plus 1 squared, and b is y minus 2 squared, that equals c squared. The distance we know has to be 3 between P1 and P2. So the hypotenuse in this case we know is 3. So 3 has to be squared, because a squared plus b squared is c squared. And that's 9. Okay, 3 squared is 9. This actually is the equation okay, you can end up here. And but if you want to do more, you can do that. Choosing the square root, the right hand side, choose the square root. You have a square, choose the square root is 3. The left hand side you can write in this way. Okay, so you may stop either here or here. Both are correct. This would be the equation. Okay, and then you can see this P2 can be here. This P2 can be anywhere on this circle. Okay, for example, it can be here. Okay, and then you will see actually this equation express the line, express the circle with the center P1, -1, 2, ending points right here. Radius is 3. The distance 3, radius is 3. Okay, so this is actually the equation of the circle with radius 3 with center -1, 2. Okay, so that's the solution for this one. If this center sometimes can be here, okay, think about that, what the equation would be. Okay, in this case, this is the center of the circle, the radius is 3. I'll see you next time.